screencast will explain how to summarize the PJ density data for the density analysis. So after you've used your QR code, everyone's entered their data. It should come in looking like this. This where you'll have a group name. Hopefully it's short for each of you. And then you'll have a site, point number, and then each of the 4 distances from the random point, then a space, and then the number of trees in each quadrant. Now the first thing I'm going to do is make a little space. I'm going to work here in the H area. So I'm going to select the entire I column by clicking on the I, and I'm going to move the tree quadrats off to the right. Now if you'll notice those tree quadrats are ordered. We'll deal with that because I've already sorted them. We'll deal with that in a bit here. Let's take a look. Now this is our data. The first thing we're going to do is we're going to calculate the value that we call A bar, which is the average of the 4 points. And to do that, I'm simply going to write equals average, and then I'm going to select those 4 points straight across, okay? The average. The next value that I'm going to want to have is the square of that. So this is going to become A bar square column, which is equal to whatever's in the cell next to it, raised to the power with a caret of 2. That's the caret, which is just above the 6, and that gives me that cell squared. And the last one I'm going to put over here is equal to 1 over the A bar squared. Sorry, I put it over there. 1 over A bar squared, which is going to be equals 1 divided by whatever is the A bar squared. All right, so that number there becomes our estimate. I've got it highlighted now. That is our estimate from this single random point of the density of trees in this habitat. All right, now I did them all at the top. Now I can simply drag them all down to the bottom here. And now I have 40 different estimates, okay, of the A bar square. Now those 40 different estimates can then be used, for example, to plot the mean, the standard deviation, the variance, and all those things from that particular piece of data. Let's go ahead and do all that because I'm going to make a little more space here on the side. Pull this. Whoa! Sometimes this happens. It happens. It happens to everybody. Okay. There I'm making a little more space. So the statistics that I'm going to want to calculate here, I'm going to write at the top of my page. I'm annotating them so I can see them. One is going to be average of A bar. Average of 1 over A bar. I'll put like this. The next one is that's the mean of all these things here, right? Each of these estimates. I'm going to want to know the sample size, and I'm going to want to know the standard deviation. I'm going to want to know the variance. I'm going to want to know the standard error of the mean. And I'm going to want to know the twice times the SEM. Okay, so all that will need to be known for us to make our graph. The average of these things will be equal to the mean of them all equals the average of all of these estimates of density. And there we go there. Boom, that's done. And the end, this one you got to count. There's no real other way to do it. Just look at the number. There are some ways. This is the easiest one. It looks like we're starting in the 3rd row. So we're going from 3rd down to 41. So that means we're at 39 samples. So I'm going to put N of 39. The standard deviation will be equal to STDEV of these observations. And oops, not that observation. These observations here. You know, if Excel is giving you a hard time, you can use the Shift key and hold. And I'm going to need the variance. Notice this is the standard deviation from a sample and the variance from a sample, which is just var or var. And if we have to use var.s, depending if you're using a PC, sometimes it likes you to use the S notation. That's fine. And then the SEM. Now we should remember that the SEM is equal to the standard deviation divided by the sample size here. Nope, not just sample size, but divided by parentheses SQRT of the sample size right there. And I usually put the parentheses in to make sure it calculates in the right order because sometimes it does not. And this is going to be equal to 2 times whatever's in that cell there. So that is 2 SEMs. So this is going to be what we're going to use for our error bar, and this other one up here is we're not going to use that other standard deviation in our measure. Now, gosh, we're just about done here. I'm really tempted just to finish up, but I'm going to keep this data here, and let's go ahead and move into quadrats because we're going to do the quadrat data and we're going to put that together with this information into your graph. You have another group of instructions for making your graph. Notice that you're going to want to use the graph information that you need for a graph for this class are these 2 bits of data. You need the mean of the estimates, and you need that's 2 times the standard error of the mean of those estimates. Now let's whip over here to the trees in quadrats. This is a totally different sampling method using the quadrats. I have ordered them already, so let's take a look at what I did there. I'm going to go into N. There are the same number of samples here, and I've already calculated an average. I'm going to get rid of that down there. These are my numbers of trees in quadrats. Now, what you can do is go to the data menu at the top of the screen, and then you can sort them. Now, the quick sort is the easiest one, A to Z, which I've done. You could do Z to A, and it will sort from the biggest one to the smallest, or you can go A to Z. It doesn't matter what line of data they came from anymore, because we're not comparing within Frisbee tosses. We're just looking in general at the whole data set collected. So there we've got the whole data set collected. Now, from all that data, what I'm going to want to do is I'm going to do the same actual values here. I'm going to want those in the same way that I have them over there. The other thing I'm going to want is I'm going to want to convert these things to trees per meter. So this is going to be, I'm going to put this as X trees divided by 25. And the reason I put trees divided by 25 is that this is the number of trees per 25 square meters, and I want the number of trees per 1 square meter. So I know that this number is still going to be 0 for these guys, and I know if I try to do the math, it'll give me some kind of an infinite number. But here I'm just going to take the first number that's positive, and I'm going to say put that number divided by 25. And this converts to the same units as we have for the distance measure. So we drag that down. Now, all we need to do is calculate the average of these things here, which is going to be simply done. Let's do it. Equals the average of all this stuff. Now, if you don't like doing it by sliding, you can just push the Shift key and click, right? Highlight the top cell, Shift, go highlight the bottom cell. Sometimes a lot easier than having to motor through all the cells. N is going to be the same number of N. You might want to double check, but I'm pretty sure you should have 39 samples here as well. The standard deviation is STDEV equals STDEV, parentheses, again, click, click, close, hit return, takes me to the top, equals variance. Variance. Why are we doing the variance? I hate to call it busy work, but we should all know how to do the variance. It's pretty easy to do. And the SEM now becomes a little bit tricky because remember, it is the standard deviation divided by the parentheses SQRT of the sample size, which is 39 in this case. And so 2 sets of parentheses make that good, clean calculations, and 2 times that will then be equal to 2 times to the asterisk times the SEM, and then we're done there. So you'll notice right away that the error bars are going to be a little bit bigger for this guy, almost 3 times as big, and the information, I'll highlight the information again that you'll be needing here. Let's go back to the home menu. It'll be this guy and this guy. Now these are the only 2 bits of information, the mean, the number of the distance up for the error bar and the distance down for the error bar. And with that information, you can make a bar graph. So get going and compare these 2 guys, and Gosh, I just want to do it. We should just do it. Let's just do it and see what happens. Okay. To get started here, what I'm going to do first is put the data next to each other. So I'm just going to copy all this. And I'm going to paste it over here as values by control pasting, paste special. I'm just going to paste as values, and that will give me a little better head start here. Now I'm going to go ahead and insert a graph. I'm going to insert my bar graph. I hope it goes well this time, because it changes every time they do it. Ah, that's awful. That's not the bar graph I wanted. I wanted the bar graph for those two things. Let's try that again. I'm going to highlight those two things first. Oh, I need a title. Let's title. I got to put the title here. So this is using the quadrats, and this is using point quarter. Okay, which is the distance measure. And let's see if this is a little bit easier this time. Let's see if that works. Oh yeah, it nicely put my titles in there. Everything's looking great so far. I guess now I need to figure out how to put in my error bars, which I need to move this out of the way to see in the first place. But notice how I have quadrats titled and I have point quarter down here. And oh, this is looking great. So now I need some error bars. So how am I going to insert those? Let's try formatting. Now I know for everybody who knows how to do this. Add chart element. That's what I was looking for. Add chart element. This time I'm going to put error bars in there. I'm going to do more error bar options because I want to do them myself. I'm going to go up and down. I want caps. I want a fixed value up and a fixed value down, and I'm going to say the error amount. There you go. I'm going to hit custom and specify the value. And for the positive error value, I'm going to use these two values here. All right, notice how I selected both of them. And for the negative error value, I'm going to select these two. Now I had to highlight those so I didn't get an extra bracket in there. Notice how I highlighted that whole thing. And let's see if it works. Oh, it works beautifully. Oh, I love this. So the last thing I'm going to do is I'm going to get rid of this fill that's in here. So I'm going to do chart. Can I change my colors? Do you think it will do that? I don't want more colorful. I want less colorful because I can't fully see my error bars under there. So what I'm going to do is do format, shape fill. Did that help? It did not. It did not help. Maybe I'll try it here. All right, well, you have to tune into the other one to figure out how to do that. Ah, that doesn't look very good. No fill. Still unable to get it filled in, so I'll just have to deal with it at another time. It works okay like this. Okay, so that is the end of my screencast there. Notice the error bars are not the same, and the overlap here is very close. So the t-test could show you these are different, or it could show you they are not. The only way to know that for sure is by using the actual t-test. You can put your chart title in here. Please title it as something that you like.